Right, so when looking at 1.1, finding and using rates, and 1.2, walking rates and linear relationships, what I want you to think about is your information and your data and how this applies. So when we look at Alana here, you can see that she walked 10 meters in 10 seconds, which reduces to 1 meters per second. So you can see that division problem right here, like you did for your walking rate. So she walked pretty slow. It took her 10 seconds to walk that 10 meters, so that's 1 meters per second. Gilberto, on the other hand, he walked faster. He walked in 5 seconds. So you can see that his unit rate is 2 meters per second. One thing you need to keep in mind is the higher the unit rate, the farther you're walking per second. So he's walking 2 meters in 1 second versus Alana, who's slower, is walking 1 meter in 1 second. Leanne seems to be the fastest. She walked in a total of 4 seconds, so that gives her a walking rate of 2.5. So now basically what you do is you go to your table like you did yesterday in your assignment. And yesterday basically you filled out the table based upon the information using the calculator. So Alana's pretty easy. She's 1 meter per 1 second, 2, 3, 4, so on and so forth. And now basically you can see the table filled out to its capacity. So you have 3 examples, Alana, Gilberto, and Leanne. In your groups you have 3 group members that walked at different walking rates. Yours were decimals, not whole numbers, with the exception of Leanne. So you can see that each person is progressively faster. Alana's walking at 1, so she ends up in that 10 seconds. She ends up at 10 meters. Right here you can see in 10 seconds she's at 10 meters. Gilberto's further. He's at 20 meters, so he's double her distance. And you can see that this is Leanne. She's at 2.5. She's the fastest walker, and you can see that there. All right, so that's basically how you would create a table based upon their rates. But from there, we need to come up with some information, some conclusions. So you have 3 people with 3 different walking rates, 1 meter per second for Alana, 2 meter per second for Gilberto, and 2.5 meters per second. We can basically figure out a lot of different things based upon their rates. So one of the formulas we need to commit to memory is distance equals rate times time. Okay, so we can abbreviate these to D equals RT. Okay, no multiplication symbol is necessary when you use two variables. You assume that you're multiplying. So we know the rate for each individual. So each individual person has their own formula. All right, so we can kind of go from there. So Alana's formula would be distance equals 1 t. Okay, so 1 meter times however many seconds she walks would be t. Gilberto would be d equals 2t, and then Leanne would be d equals 2.5t. And you could see for no matter what time I put in there, I'll get my answer by multiplication. So if I know how long that Alana is walking for, I can just simply put in a time and that will give me the answer. For example, if Alana was 30 seconds for t, I could figure that out by multiplying 30 times 1 and get 30 meters. Okay, that gives me the distance. Okay, same thing with Gilberto. If I do 2 times 30, I get 60 meters. He's double. Okay, and then finally the same thing with Leanne. If I put in 30 seconds, I'll know that she walked a total of 75 meters. So that will help me in the future, okay, by creating that formula. All right, so the next part of this is really important, that D equals RT, okay? This formula can be written algebraically in a different way. It could be written as y equals mx plus b. So it is a formula that we're going to get to know very, very well. So y equals mx plus b. We're going to get into this more and more as we go along, but what you'll notice is M and R, okay, are the same thing. Our rate or our slope. M is slope. Okay? X is our independent variable. In this case, it's time. Okay? And Y is our dependent variable. In this case, it's distance. All right? So we could have lots of different Y's and X's depending on what we're working with. So D is the Y, distance is the Y, but whatever our dependent variable is would be the Y. Okay, and our independent would always be the M. And the independent variable would be the X. Sorry, the rate would be whatever we come up with, the slope. B we'll get into a little bit later. There is no B in this. The last thing I wanted to talk to you about is how to graph this and what that would look like. So real quick, this is a graph and what it looks like.